Ignition sequence starts.
Good morning, and welcome to Mission Control Houston at NASA's Johnson Space Center. You've got a view into the International Space Station Flight Control Room, where a team of specialists is monitoring systems on orbit and working with a new expedition crew. Station Commander Oleg Skripochka and his NASA crewmates Drew Morgan and Jessica Meir are in their first full day together as Expedition 62, following Wednesday night's departure of 3 crewmates and completion of a record-setting mission.
Welcome to Space to Ground. I'm Kayla LaFrance. On top of the normal hustle and bustle of science research and life aboard the space station, the crew prepared for a special homecoming. Russian cosmonaut Alexander Skvortsov, along with Luca Parmitano of the European Space Agency, and NASA astronaut Christina Koch returned home on Thursday after completing their Expedition 61 mission. Before their stay on board ended, Parmitano handed over command of the station to crewmate Oleg Skripochka of Roscosmos. Then the 2 crews said their farewells, the hatch was closed to the Soyuz MS-13 spacecraft, and the returning crew undocked from the station's hoist module. After the nearly 4-hour journey, the crew landed safely in Kazakhstan and was greeted by a recovery team who transported them to Karaganda before they parted ways to head off to their home nations. Parmitano and Skvortsov spent 201 days in space, having launched with NASA's Andrew Morgan last July. Morgan will remain on the station with the rest of his Expedition 62 crewmates until their return to Earth in April. Koch set the record for the longest spaceflight mission by a female astronaut after completing her 328-day-long stay aboard the space station, surpassing the previous record of 288 days held by NASA astronaut Peggy Whitson. Not only did Christina set a new duration record, she also participated in the first all-woman EVA with her friend and crewmate Jessica Meir back in October of last year. The 2 of them would go on to perform 2 more EVAs together. This week, Koch reflected on her multi-record-breaking mission.
Well, for me, it's just all about the honor that I feel to follow in the footsteps of my heroes, and hopefully I can make it about paying homage to them. They're the ones that paved the way for us to all be where we are today. And also I look at it as an opportunity to hopefully inspire the next generation of future explorers. I know for me it was important to see people that I saw a reflection of myself in growing up when I was envisioning, what I could do with my life and what my dreams might be. So the idea to maybe be that source of inspiration for someone else is just such an honor, and I hope to carry that forward even when I'm back on Earth.
Koch's time in space will also provide researchers the opportunity to observe effects of long-duration spaceflight on a woman as the agency plans to return to the moon under the Artemis program and prepare for human exploration at Mars. During this record-setting mission, Koch spent many of her hours on science activities aboard the space station and wore many hats: farmer, biologist, physicist, engineer, test subject, and many more. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The longest ever single space flight by a female astronaut lasted for 328 days, 13 hours, and 58 minutes. Christina Koch is in 7th place for most time spent in space among all American astronauts. A few days before her departure, Koch recalled the biggest surprise of the mission and the most memorable item she received on a cargo flight.
In the beginning, the surprise was just that this place actually existed. But more recently, the surprise that I've uncovered is the human body and mind's ability to adapt to any situation. For example, I sometimes joke that before Jessica got here and before I, heard her all the time exclaiming about how exciting and fun it was to float, I think I had actually forgotten that I was floating. The human mind just has an ability to really accommodate any situation and to turn it into normal. So, for example, the fact that we can just work right on the ceiling like this and not even know the difference between the two. It's really been an exciting and a huge surprise to see that life up here can actually become normal because of what our bodies can adapt to. I'd say the most memorable item I've ever received would be handwritten letters from my husband. No matter what, things that people send up and take the time to make me or write me, physical things that I can hold mean the world. I've gotten 2 handwritten letters from my husband, and they're always from months before. So, for example, I got one in October that he wrote in July because of the due dates of our items. So the letters aren't necessarily relevant to the moment, but the fact that, you know, they can express things and that it's something that someone you love on Earth actually was holding in their hands is really special.
During her record-setting flight, Christina Cook spent a large portion of her time on science activities. Here's a look at some of her research highlights as she talks about the roles and responsibilities she had during almost 47 full weeks off of the planet.
First and foremost, our responsibility is to our crew up here to keep each other safe. Secondly, I would say our responsibilities are the work, the amazing work that we do as part of this orbiting laboratory. As a microgravity laboratory, we do science in all kinds of different arenas, from physical science to biological science, human research, technology demonstrations, and many more. So doing that work and carrying out the work that is the purpose of the International Space Station is definitely one of our responsibilities. And I also think that we have a responsibility to the people that we represent up here, to carry people's dreams into space with us, to communicate the perspective that we have up here.
Okay, copy that. I'll step through on my own for the setup and let you know when questions come up. And yes, we definitely are all doing this as a we and as a team. So you all will be installing the test cartridge as well.
We have a series of tasks that we're asked to do, and we know that it's going towards a good cause, that it's benefiting the Earth, and that it's advancing the cause of exploration for all humanity. So being able to participate in that every single day is such an honor, and I'll definitely miss that. The microgravity environment is a lot of fun. It brings about a lot of interesting changes in the human body, and obviously it enables the amazing science that we do here. When I think back about the legacy of this mission, I think the thing that I'll be most proud of is just bringing my best every day and contributing and giving back to this program that has allowed me to be here, has allowed me to work for, you know, a mission that I've believed in for my whole life, to my training teams, to the teams on the ground, the engineers, the planners, and the flight controllers that make everything possible. And like I said, just remaining vigilant in meeting the challenges every day up here, and just remembering that it's all about giving back and contributing.
Christina Cook's long trip wrapped up its final leg just a few hours ago when she arrived back in Houston on a NASA plane. The only American who has a longer space flight than Christina Cook's is Scott Kelly. And when he was here at JSC last week, we asked him if he had any advice for Christina about how to get used to being back on Earth after such a long flight. He did.
Hey, I wanted to congratulate you on a very successful mission. Look forward to you getting back here on Earth. So really an incredible experience and privilege to come back from space after living off the planet. Strictly up to you, I guess. It's whatever you're craving. In my case, I craved fresh vegetables because we didn't have a whole lot of that on board, as you know. I would encourage you to put everything in the right perspective and understand how important it is for you to get the right amount of rest and balance all those things you want to do because you haven't been able to do them in so long. One of the challenges of coming back to Earth after being in space for so long is that your whole time there you have this very tightly controlled schedule. And one of the things I always found hard to adjust to is when I come back not having that plan anymore. And the advice I would give you is, tell your own story. Let people know how you really felt, what you thought, what your feelings were while you were on this mission. Try to inspire, entertain, inform. But the most important thing is you got to be genuine. When you come back, it's somewhat like a sensory overload a little bit, experiencing weather for the first time, rain, sun on your face, wind. I mean, it's exhilarating. I do remember, though, the first time I saw a dog, like up close after I got back, it was almost like seeing an alien being. It's how I felt about it. It was really cool. So seek out a dog if you don't have one.
And now, Expedition 62, which will feature Oleg Skripochka, Drew Morgan, and Jessica Meir on board for about 2 months until the next Soyuz vehicle arrives. Meir is more than halfway through her first spaceflight, putting into practical use some of the education she acquired in years of space station mission training. And that, of course, was on top of what she learned, earning a bachelor's degree in biology, a master's in space science, and a doctorate in marine biology. Yet little of that formal education much mattered when she agreed to sit down with us before she left Houston for some non-technical questions. Take a look.
The clock has started. Roger.
What's your favorite color?
Green.
Favorite book?
Anna Karenina or Galapagos by Kurt Vonnegut.
Favorite song?
Probably anything by The National.
Are you a morning person or a night person?
Definitely not a morning person.
What's one thing you're afraid of?
My plant's dying while I'm on the space station.
Who is the person who makes you laugh the most?
My best friend from college, Jacqueline.
What is something you do outside of work to have fun?
Spend time in the outdoors and nature, hiking, skiing.
What's your favorite animal?
Probably an auk, a seabird, like a murre.
If you could have one superpower, what would it be?
Definitely to fly.
The most valuable high school or college class that you ever took?
My introductory biology class at Brown.
Most important advice you would give to your younger self?
Appreciate and enjoy the moment.
Who inspires you?
My mentor from grad school, Jerry Koyman.
What's a goal you plan on achieving this year?
To fulfill my future plans from my high school yearbook to go for a spacewalk.
If you could spend one day on Mars, what would you do there for fun?
Explore. Maybe some kind of sand dune surfing.
Meir and her crewmate Drew Morgan and their astronaut colleagues like to say that they are just the tip of the spear, a small part of a large effort to explore space. In this case, they're doing their part on board the International Space Station, which is a laboratory offering a one-of-a-kind environment for scientific research. And today we kick off a special series looking at some of the other people who make the program work, the scientists behind those experiments. Maestro, cue the overture.
Feeling weighed down? Feeling the constant pull to the Earth? We all are. It's gravity, and it's a part of every single thing we do, including our science. But what if we're 250 miles above Earth, aboard the International Space Station, a laboratory like no other that offers something we can't get on our home planet?
My name is Dr. Serena Anand-Chancellor, NASA astronaut. I recently flew to the International Space Station aboard Expedition 56 and 57. My relationship with microgravity is that I got to live in microgravity for 197 days when I was on orbit. So many people ask, what is microgravity? Why do you float on board the International Space Station? Gravity acts upon all objects. We're never truly in zero gravity on board the space station. But because the space station is traveling so fast around the surface of the Earth, we're actually in a constant free fall. And that's why everything and everybody appears to float on board the space station.
We are experiencing the Earth's gravity. In fact, we're actually experiencing about 90% of what you all experience on the surface of the Earth. The difference is we're just moving so fast that as we fall, we actually fall around the Earth, and that defines orbit. So microgravity means we're not, it's not the absence of mass, which of course creates gravity, but all the objects together are in the same gravitational field and all falling together. So yes, it is a lot of fun. Floating around, of course, is one of the exciting parts of being up here on board and being an astronaut, but even more importantly, it lends itself to all the amazing experiments that we can do on board that take advantage of that microgravity environment to do things that we can't do on Earth, but that can benefit life back on Earth.
The important thing is it's so different than what we have here on the ground, where everything is pulled by the Earth at what we call one force of gravity. And what that does is it allows you to see the small forces, the small processes, the small effects of what goes on in life cell development or technical processes like combustion or fluid flow. And it helps you understand things that you may not have fully understood on Earth, where you see something happening, something assembling or disassembling, or the shape of something now going into 3 dimensions. And you learn, that's really what was driving this thing on Earth that we didn't really understand.
On Earth, gravity is affecting all research we do, and sometimes that can get in the way. Studying things in different environments can give a better picture of how they work, from diseases to fires and even things that make up products like milk or shampoo.
One of the main things we perform on the ISS is science. In fact, probably 70 to 80% of our day is performing scientific experiments.
The International Space Station is a great place to do research for several perspectives. One of those is it's a big, huge satellite orbiting the Earth. So if you have an instrument that wants to look at the Earth or look out at space, we provide the power, we provide the data, the platform for it. You don't have to go do your own new satellite. The outside of the ISS is also a very extreme environment, and sometimes you learn things by exposing your hardware, your polymers or whatever, to a different environment. You'll see something happen different than what is on the Earth. But probably one of the most pervasive uses of the ISS is just the microgravity environment, the things that we do inside the ISS. To be able to do your experiment in space without gravity, which we've all lived with forever here on the ground, which we live with every day, and we don't even realize how it governs so many things that happen around us. If you take gravity away, now some of the small phenomena, some of the small processes and forces start to come out, and you can see them, and you can see the behaviors of your experiment happening differently in space and in microgravity than you would on the ground.
It takes a lot of people to make all of that microgravity science happen. 4,000 scientists, companies, and students from over 100 countries have sent more than 2,700 experiments to the orbiting laboratory. Over the past 20 years, these studies have unlocked new discoveries and even kicked off hundreds of new microgravity experiments.
We're studying the physiology of how blood flow and the fluids in our body shift as a result of microgravity.
Yesterday, I spent some time setting up a veggie experiment. We'll actually be growing Mizuna lettuce up here.
Drew and I actually have been helping start a new experiment called the Cold Atom Lab, which will create one of the coldest places in the universe right here on the space station, almost at absolute zero.
But who are these scientists? And how do they get their research to the space station? This season, we'll take you behind the scenes of the years of preparing an experiment for space. You'll see it launch off the planet and splash back down in the ocean, and hear what it's like to hand off your research to the astronauts who serve as the eyes and hands of the scientists aboard the International Space Station.
This is our first project that is going up to the station, and our first project working with anyone involved in the space program. So it's a very exciting time for us. It'll be interesting to see how all of our planning is played out when someone else has the experiment in their hands.
International Space Station crew members are the test subjects in some of the experiments on board as scientists work to figure out how being in space impacts human health. And that includes studying how the crew members establish a routine for sleep, which is key to their functioning to the best of their ability. In this This demonstration video, astronaut Ricky Arnold talks about some of the problems with sleep in space and shows us how the astronauts overcome them.
Hi, my name is Ricky Arnold on the International Space Station. We get asked a lot, how do we sleep in space? And it's a great question because we all know how important a good night's sleep is. If you're not getting a good night's sleep, you can count on reduced cognitive function, poorer reaction times, and maybe just being a little grumpy. And up here in space, just like on Earth, those are things we all want to avoid. So, we go around the Earth about every 90 minutes, which means we get 16 sunrises and sunsets a day. So how we sleep is a really good question because the sun's always getting ready to come up or it's getting ready to set. And we use those cues on Earth to let us know when it's time to begin our day and when it's time to end our day.
Ricky is talking about circadian rhythm. It's the body's natural regulator for sleep and wake cycles based on a 24-hour schedule. Those 16 sunrises and sunsets he mentioned can cause circadian misalignment and sleep deficiencies during long-duration spaceflight. The hazards of lost sleep can range from poor attention at school to on-the-job errors to long-term sleep loss, even chronic disease. Sleep is super important. Hey Ricky, what are you doing on the space station to get some sleep?
Well, here in space, we kind of have to do it artificially. So we have these nice crew quarters. It's about the size of a refrigerator. It's very quiet. The space station can be a little noisy, but it's very quiet in here. And we can control light with a light switch. If we are just middle of the day, we have a light like you're seeing right now, which is just this kind of standard lighting. It's getting close to the end of the evening. You want to dim the light a little bit, kind of for the end of the evening. Or if you're going to be up late, you need to keep awake, we have a really bright light setting. The other thing we have is off. You see how dark it got. Another challenge sleeping on the International Space Station, sleeping in microgravity is really nice because you can just float and stretch out and it's really comfortable. The problem is with the air currents in the International Space Station, you could very well float into a piece of hardware and hit your head, or worse yet, even break something. So we got our sleeping bag here, just almost like a sleeping bag on Earth. But as you can see, we have bungee cords that help hold us up against the wall. So I almost sleep standing up. And also, I do have a pillow. It's just a bag full of clothes. But I actually keep it up on the top of my head because I'm a little tall. In the crew quarters, I tend to hit my head on the ceiling when I'm sleeping. So I got my sleeping bag here. I got my bungee cords to hold me in. And then when it's time to go to bed, it's quite easy. Just unzip the sleeping bag, climb on under the bungee cord, climb into the sleeping bag, make sure you're nice and secure, zip yourself up, plan on getting a good night's sleep so I have good reaction times, my cognitive ability is what it should be, and that I'm not grumpy in the morning. So with that, I'm all set. Good night from the ISS.
The opportunity to spend 6 or so months on the International Space Station, as men and women from around the world have been doing without interruption for more than 19 years now. That's led to the development of new technologies for space exploration, groundbreaking scientific discoveries, and an experience of cooperation among nations while fostering the commercialization of space and spaceflight. And even more than that, it's caused many of the astronauts to experience a shift in their worldview. NASA's Karen Nyberg is one of them.
My first flight was 2 weeks, and a lot had to get done. I distinctly remember the point when I stopped and thought, I did it, I'm here. My goal was to be an astronaut, and now I'm in space. I remember seeing the beauty of Earth, but I don't remember any more profound thoughts about it at that point. I think it was when I got into my long duration flight and spent a little more time that I really just started to take it in a little bit more. The entire experience is actually very surreal. First, you're launched on a rocket. You're pulling G's as you're going out of the atmosphere. You're looking at the Earth for the first time. You're floating. Everything is different, and it just is all just such a different experience that it almost doesn't seem real. In fact, when I did my space shuttle flight for 2 weeks in 2008, when I got back, you could have convinced me I never went, probably, if there weren't pictures. This experience is so unusual and so different than anything you've ever done in your life that it's hard to grasp it all. And I was very excited then when I got assigned to a long duration because I thought it's going to burn in my memory and all that, and it was the same thing. I came back and my memories were there, but it almost didn't seem real. Looking at the Earth for the first time, you just notice the vibrancy of it. It's so bright. Pictures don't do it justice. It's equivalent to me of backpacking out in the mountains where you're trekking along and then you come to a clearing and you're overlooking some valley and the sun is setting and it is, you're like, how could this get any prettier? And you take a picture and then you go back and look at the pictures later and you never have that feeling again. It never brings about the feeling that it did. And same with watching a beautiful sunset or a sunrise. I have not seen a picture that gives me the same feeling that I felt when I looked with my own eyes. It started to make me understand that everything is connected. What is happening in the ocean over here can affect what is happening on land over here. It's just all one being, and it's all interconnected. And so I think we tend to live in our bubble of our world that's here, and it's hard to think about other people on the other side of the world and be empathetic toward them, really, because you don't know them and you don't know their situations. And I found seeing the Earth really changing that perspective for me. And then listening to a news story in the morning and flying over that particular part of the world in the afternoon, it really affected me. And then just realizing, it's home. Often we think home, and right now home is Houston, Texas, and childhood home is Minnesota, but home is Earth.
If you want to get another look at any of the stories we featured today, check us out on YouTube and Facebook, and there are the particulars about where to find it. While you're there, look around because there is lots of other cool stuff you can find about NASA and America's human spaceflight program. If you're going to be out on the internet anyway, check out Houston We Have a Podcast. We talk to folks about their work in all aspects of space exploration. The new episodes post every Friday. Today, Gary Jordan talks with NASA artist and graphic designer Sean Collins about the rich history of mission patches and emblems and insignia that dates all the way back to the Mercury program. The patches, that is. Go to nasa.gov/podcasts for today's episodes. It's where you'll also find all our previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.